So we saw an interesting situation in that last example there, where we had a complex number times a complex number, and we ended up with a real number. And that's because we had a conjugate. We've seen conjugates with radicals so far. And so the conjugate of a plus bi is a minus bi. All the conjugate does is change that addition sign to a negative sign. Everything else is exactly the same. So here we have two conjugates, 5 minus 2i and 5 plus 2i. All right, and so let's see what that comes out to be when we multiply that. 5 times 5 is 25. 5 times 2i is 10i. Negative 2 times 5 is negative 10i. And negative 2 times positive 2 is negative 4i squared. I times I, there's I squared. And what happens to the middle ones? They go away. We're left with 25 minus 4, and that I squared will become negative 1. Okay, which is 25 plus 4, which is 29. All right, so again, we started with a complex number times a complex number. Remember, a complex number is something written like a plus bi, where a and b are just numbers, so 5 minus 2i. And we ended up with no i's in the answer, no imaginary number at all. Okay? Well, that's kind of interesting, so let's generalize it. Let's make this a plus bi, a minus bi. When we generalize things, we learn what always is going to happen. So a times a is a squared. A times negative b is negative abi. Bi times a would be positive abi. And positive bi times negative bi would be negative b squared. And I times I is I squared. And what happens to the ABI's in the middle? They go away. And that leaves us with a squared minus b squared times I squared. But I'll write the I squared as negative 1, which is a squared plus b squared. And we're done. Now, a and b represent real numbers. They could be 5 and 6, or 2 and 3, or a negative number, or whatever. But the key is this. We started with a complex number times a complex number, and we end up with no i's. So this represents a real number. Okay, no i's. And so this gives us what we call our complex conjugate product rule. So if we have a plus bi times a minus bi, we get a squared plus b squared. Okay, you'll notice this is the imaginary version of a difference of two squares, but this is the sum of two squares. Okay, we get imaginary numbers here. So, now we talked about adding, we've talked about subtracting and multiplying. So what's left is dividing. So when we're dividing complex numbers, the key is to make the denominator real. Make the denominator real, and then we'll distribute the denominator to write it in the form a plus bi. So we want it to end in the form a plus bi. All right? So we're going to make it real. We've talked about rationalizing the denominator. Well, now we're going to realize the denominator, if that's right way to say it. We'll say it that. Let's realize it, okay? Do you realize what's going on? Let's find out. All right. So if we have 4 minus 3i on the bottom, all right, so we want to divide this. So when we think of division, again, let's just think of making the denominator real. We want to get rid of the i's. Get rid of the i's in the denominator. That's the key. We want to make those i's go away, just like we wanted to make the square roots go away when we were talking about radicals in the denominator. Because the I really is a radical, isn't it? Well, if we had side notes here, if we had 6 plus 2 times the square root of 5 over 6 minus, 4 minus 3 times the square root of whatever, 5. What would we do to rationalize the denominator there? We multiply this by 4 plus 3 squared of 5, right, on top and bottom. Okay, that's how we would rationalize that. That's the conjugate. Well, we're going to do the same idea here. What's the conjugate of 4 minus 3i? Well, the conjugate is 4 plus 3i. Again, we only care about the denominator, not worried about the numerator. But what you do to the top, the bottom, you got to do to the top, because we're really just multiplying by 1, right? Keep in mind, this is just a fancy version of 1. Okay, it's just 1. And when you multiply by 1, the value doesn't change. Okay, so now on the bottom, we can distribute this. However, it's going to come out to this. It's going to be the first thing squared plus the second thing squared. Okay, so if you multiply it out, you're going to get the first thing squared, 4 squared, plus the first number times the second number, ignoring the I. So it's plus 3 squared. Okay, that's what happens when you multiply conjugates. All right, now if you forget that, then go ahead and multiply it out. It doesn't hurt anything. All right, but I want you to see you can use that rule there. Once you understand what's going on. Now the top, we have to multiply out. We've got to multiply this out. 6 times 4, 24. 6 times 3i, that would be 18i. 2i times 4 would be 8i. And then 2i plus 3i, that would be 6i squared. Okay? So on the top, we get 24 plus 26i. And this is going to be 6 times negative 1, right? So I'm going to go ahead and write that as negative 6. Okay, and we'll clean that up in a second. The bottom is 16 plus 9. And we're almost there. 24 here minus the 6. Let's combine those. 18. And 25 on the bottom. Okay, now we're almost done. The last thing is we want to write this in terms of in standard form. We call this a plus bi, standard form for complex number. And the problem is this isn't because of the fraction. So let's divide this out. Which number does this 25 divide? Does it divide the 18 or does it divide the 26? The answer is both. So this divides both of them. It's kind of like the division version of distribution. So the 18 is going to get divided by the 25, and the 26 is going to get divided by the 25. 26i, we could say. Okay? Now, 26i in a fraction, this I can be up top, or it can be, this is 26 times I, right? Okay? So we can also take that I and we can put it out here. The reason is because this is like I over 1. And if you went ahead and multiplied it together, it'd be 26I over 5, right? But we want it in this form because it's A plus BI. That's our final answer. If you could simplify either of those fractions, go ahead and do it, but we can't. Okay? All right. One more little example here. All right, that was kind of the full deal there. What if we just have an imaginary number at the bottom, just a 5i? Well, we want to make that go away, so we can multiply by 5i or negative 5i if you want to kind of keep that conjugate idea going on. But just multiplying by 5i on top and bottom, because that's going to give us I times I, which is going to be I squared. That will be good enough. If you want to, again, if you want to make it negative I, it's going to come out the same in the end. Okay. Remember to put parentheses around these binomials. Okay. That's easy to forget because you got to multiply this to both. So we have 15i squared minus 5i times 4 is 20i. And we have on the bottom, we have 25i squared. So 15i squared is going to be negative 15. and then minus 20i. And on the bottom we have negative 25. Okay, because that's negative 1 times 25. And now let's divide them. Negative 15 over negative 25. That's obviously going to be positive. I'll clean it up in a second. And then we have negative 20 over negative 25. Maybe I'll go ahead and fix those negatives right now. Let's just fix those negatives. Let's not mess with it. Okay, those are going to cancel. Gone. All right, and so it's going to be positive 20 over 25i. And we can simplify these fractions, divide them both by 5 there, and we end up with 3/5. Divide these by 5, and we have 4/5 I. That's the idea. All right? So there you have multiplying with, actually dividing with complex numbers. Okay? So we can add, subtract, multiply, or divide. All right, last little bit here we want to look at is what happens when we have exponents or powers. All right, so let's look at a pattern here. All right, I to the first power. Well, I to the first power is just I. I to the second power we know is negative 1. We talked about that. What about I to the third power? Well, I to the third power is like I squared times I to the first, right? Well, I squared is negative 1, and I to the first is I. So we get negative I. Okay? All right. I to the fourth. Well, what's that? Well, that's like I squared times I squared. Or if you want, you could say I squared to the second power, right? Either way, we're going to get, in this case, negative 1 to the second power, because I squared is negative 1. And negative 1 to the second power is 1. So pretty interesting that I squared I to the fourth power comes out to be 1. All right. Well, what about I to the fifth? Well, let's see. That's I to the fourth times I to the first, we could say. And what is I to the fourth? Well, I to the fourth is just 1. So this is 1i, which is I. So I to the fifth is the same as I to the first, which is just I. I to the sixth, well, that's like I to the fourth times I squared. And that's like 1 times I squared, which is negative 1. And so that gives us negative 1. Are you seeing a pattern? I to the seventh, that's I to the fourth times I to the third. I to the fourth we know is 1. And I to the third is negative I. And so that's just negative I. And I to the eighth, well, that's just I to the fourth times I to the fourth, which is 1 times 1, which is 1. Okay, so we see this repeating pattern going on. I, negative 1, negative I, 1. All right? And so a good way to do this, a simple way to do this, is just to figure out how many I squareds there are. All right? I don't know what this negative is. Ignore that negative. Let's just, this is just I to the second power. I to the second power. All right? So I to the second power is worth negative 1. So if we can write it in terms of I to the second power, we can clean this up. Okay? So for example, how many I to the second powers is this? I to the 14th. Well, this is I to the second to the 7th. And we know I to the second is negative 1. And negative 1 to a 7th power, that's 7 negative 1s multiplied together. Since it's an odd number of negative 1s, it's going to be negative 1. If we have an even number of negative 1s, they would all come out to be positive 1. Okay? Well, how many I squareds do we have here? Well, we have I squared to the 12th. 2 times 12 is 24, right? So maybe we could write this let's go first. This is I to the 24th. Because we want I squareds. And so we could think of this as I squared to the 12th, right? Because we know I squared, right? I squared is negative 1 to the 12th. And negative 1 to the 12th, since that's an even, every pair of negative 1s that we multiply together is going to be a positive 1. And so these are 6 pairs, and so this is going to be 1i, or just I. See how that works? You could also, by the way, say that there's a bunch of I to the 4ths, because we know I to the 4th is positive 1, right? So there's a bunch of I to the 4ths and 1 extra. If you divide 25 by 4, you have 1 extra. Okay? That's the idea. How about this one? Well, we want to know how many I squareds are in there. So the closest even number is I to the 50th. And I to the 50th is I squared to the 25th times I. And this is negative 1 to the 25th. And because that's an odd number, 25, this is going to be negative 1 times I, or just negative I. Okay, so we know I squared is negative 1, so how many I squareds are in there, we can break it up and clean it up like that. So, all right, well, there you go. So now we can divide, we can multiply, and we can use powers, all keeping in mind that I is the square root of negative 1, and I squared is negative 1. So that's kind of the key to it all there, all right? But in a lot of cases, we just treat it like a variable until we get to that last step and clean it up. So, all right, hope that helps. Thanks for thinking about complex numbers with me.